everyone. So welcome today for our talk. We want to talk today about what's coming next, what could be potentially the future in a post-cluster world. Do we have a post-cluster world, and how could this look like? So if you're looking into where we started, we all know with bare metal machines in the past. We went then into virtualization with like VMware or KVM. Then, of course, container were not new. They were already existing, for example, in Solaris, but really popular it get by Docker. And we faced the challenge, how do I deploy this if I not only have one individual server? So how can I manage this in a cluster world? And so Google and Red Hat started working on Kubernetes, inspired by the system Google had with Borg and open sources. So we started using, in a lot of cases, Kubernetes. We not only implemented or using one cluster, so we went more and more into a world where we have more than an individual cluster. And nowadays, we are already there that especially the ones who are on this journey from the really beginning, so already like jumped on Kubernetes 5 years ago, having tens, hundreds, or even thousands of clusters. But the question is, that's where we are currently. What's coming in the next 3-4 years? Is this already the end? Or is there something missing? And what's missing there in Kubernetes? So when we started with an individual cluster. And as an admin, I typically had full access to it. And at the beginning, we all started with like stateless application like microservices. But then it became more and more popular to also deploy a database into this. In this case, for example, a MongoDB. So question to all of you, hands up, who already deployed some kind of database into a cluster? Yeah, definitely the majority. And then, especially in bigger organizations, but also in small organizations, we started to deploy more clusters. So for example, we needed dev, a stage, and a production cluster. Or different teams needed a different cluster. So then we ending up deploying databases in all of these different clusters. And when this grow and further grow, we're ending up with a lot of clusters. Every individual users, every team needs to have his database expert in the team. And in some areas, this changed more to a platform admin or a database admin team. But this person or this team then needs to deploy and manage clusters across databases across a lot of clusters. And is this really the right approach? Having a lot of different clusters, I get challenges with like, what is when I'm running different versions of Kubernetes? What is if I'm running different operators, for example, for these databases, and how do I control this and how do I manage this? So at the end, as a developer, I don't really care about the database, how it's operated. I really want to consume a database. If I'm developing an application, yes, I need a database to store my data. But do I care really if it's running inside of my cluster, outside of my cluster, or somewhere else? I think, especially with the cloud providers, we see it, managed databases is really popular. But if I'm doing this with Kubernetes, there's something missing. I need to, for example, I'm using kubectl to deploy my stuff inside the cluster, and then potentially using Terraform to deploy the rest of my infrastructure. And how do I then bounce this into my clusters? And how can we then build up a system that I have different teams? So for example, I have my database team, I have a mesh provider team. I have a team which is specialized on GitOps, especially when we're looking into like a big enterprise organization that typically have dedicated teams for different areas. And I typically want only to consume the services. And the services can run either in my own data center. It can run also using the managed services of the cloud provider. Or it can be provided by an external service provider. At the end, as a service consumer, I really want to consume this. I don't care how it's operated. If it's running on containers, if it's running virtualized. If you're looking into like the hyperscalers, in the majority of cases, we don't know how they operated. It's a black box for us, but we have a database. We have different size of database. We can scale them up, we can scale them down, but they take care about this. But we then really want to bounce this and connect them from our application to this database or to these different services. And it's not only about a database. It could be also, I want to compose different services together. So, so for example, imagine your service is composed based on a database and a service mesh. And at the end, you want to deploy this and consume this completely with one API call. So the question is, how can we do this? And well, the first question is, how do we do this currently? In a lot of cases, especially if we are not using the cloud provider APIs, in enterprises, we have a ticket system. So we have a lot of steps we need to process. We need to request, for example, manually, please open the firewall. Can you install a new database instance for me? And so on and so on. This takes quite some time. It's typically quite manual or half automated. And I need to wait a few hours potentially, or even a few weeks to get the services, where at the end, I really only want to consume a database, an API, so that something is done fully automated in the backend. So what we really, as a developer, want to have is really this API we can talk to. And on the other side, as a service provider, so as a database provider or as the application provider, we also want to have this kind of API that we can expose our service easily to our developers. And this API should be somehow standardized. So every time I don't want to deal with a specific API for database A, I want to have a complete different way how the database is working for another service. How can this work hand in hand, and how can we manage this so that I really can manage my service and call my services on a streamlined API, different types of services, but also that the service providers can easily provide this. And that's currently something which in the Kubernetes world is not existing. And if you're looking into, for example, machine learning, it gets even more complicated. So if I have this example, I'm running a lot of Kubernetes cluster. Each team has its database running, but then they are data scientists and they want to do machine learning. So then I need to think about, potentially for the machine learning, I need to have GPUs in my cluster. Or for example, for my databases, for specific databases, I need machines with high CPU, others with high memory. So I have a lot of different workloads which needs to have different conditions on my underlying hardware. And as a data scientist, at the end, I don't care. I want to deal with data. I don't want to deal with like, oh, there's a container. There are labels at containers. What is it? I really want to work with my Jupyter notebook or potentially TensorFlow, but all the rest should be hidden from me. But then I need to have also, if I'm running this, in this example, for example, on-prem, I need a team who's taking care of the whole infrastructure I'm running. I need, if this is running containerized, someone who's expert in Kubernetes. Potentially, depending on the data and the workload, I need performance experts. And then potentially, I need also an ML ops or ML admin who helps to set up, operate, in this case, TensorFlow. And all this As a data scientist, I don't care. I really want to consume this and don't want to be an expert beside my data I'm taking care here in all these other fields already, because getting an expert in one area is already really hard. How should this person becoming an expert in all the different areas with a lot of different tools? And how can we do this better? So we have there some ideas.
Yeah, hello. So my name is Stefan. I worked for 8 years in Kubernetes. So you will find me everywhere around CRDs. So everything I'm criticizing here, I'm one of those people who invented that. And the whole community uses it. And Sebastian gave a great pitch why the world has changed. Like when you look back here, you have a number of roles which we didn't think about 5, 6, 7 years ago. There was an admin of a kube cluster and maybe application owner, that was it. Now we have many more roles. So we have roles which need a new pattern or new patterns how to provide services. So if you are in this role, like you are the IT department and you want to fulfill those roles somehow, and you want to give your data scientists Jupyter. So how do you do that? And that's basically the manifesto we want to convince you of after this talk. So we need something which is post-operator, post-cluster. Operators don't do that. Like you can install a Jupyter operator, you can build it yourself, lots of work, deploy it. You haven't solved the other roles yet. So you want something else. You will see in a minute how this will look like. And service providers, basically, everybody here is a service provider. So the ML admin provides the ML service, TensorFlow, for example. Performance specialists, they are responsible for hardware, maybe software optimization, and of course you have the typical infrastructure admins who build clusters and the normal kube admin. All those are service providers. And my claim here is kube does not support that. And many people, when they read that, so I wrote it on Twitter, and people were reading that, and my example was a database. So I want a MySQL database, or MongoDB, whatever. And it's still so hard. Like I have to install an operator to get an API which is CRD-based, and then I can create a CRD, and then I can get it from some cloud provider. It's still so complicated. It works, like you can bridge, of course, this gap here. So you can jump over it or use some tooling to connect those two streets and get a bridge. But we have built basically that. That's my claim. It's controversial. I got replies internally in the company in Red Hat. We have all those operators and people in Twitter and AWS. We have those controllers, and same for GCP and Azure. Anyway, so my claim is we don't support SaaS, software as a service, not natively. That's my point. We are building operators to bring non-native Kubernetes, non-Kubernetes APIs, so cloud APIs which are not kube native, into Kubernetes clusters. We built operators for that for 6 years. The first operator was published in 2016. And there are many teams building those operators. And my claim is we actually don't bring value in that. We have a couple of operators. When you install one for MySQL, you ask yourself, I download that from the internet. Is this maintained? Do I know the quality? Will the thing be still alive a year ago? You don't know. And the claim is we actually don't want those operators. We want that this is native in kube, that kube supports software as a service. Like I can get an API from my cloud provider of choice or my enterprise IT department of choice. I get an API, and just the API. I don't run anything, no operator, no nothing, no pod. And I can use the API and get what I want, like my Jupyter, my MongoDB, my MySQL, whatever it is. And we don't want something like that, where we have lots of glue without any value. We want one bridge and not this gap between the bridges. And the last thing, everybody knows that when you go to some Helm registry and you download some operator, is this safe? We download something from the internet, some open source project. You don't know what it really does. So that's another thing. We don't want to run anything in our clusters if I just want to consume a database. And to make this much more concrete, this is how it could look like. And again, I'm one of the inventors of CRDs. CRDs are cool. We have built great stuff with them. But I think there's a wrong tool. There's a wrong tool for the world of today. What we actually want is something like that. I can bind some external service provider API, whatever it is, a database. You know, everybody knows the famous NoSQL database MongoDB. I want that in my cluster. So I want to bind, and this can be any service provider you like, can be a cloud provider, can your IT department. So your IT department could publish such an URL, and you can bind all the services which are published. One command, very simple. And I connect, I authenticate, I use GitHub here in this case, and basically here's the API I want, and I bind. CRDs, everybody who knows CRDs, you have to think about permissions. The permission system of Kube is limited, it's airbag, it can do what it can do, not much more. And we need something else. Here's an example. So the service provider needs somehow access to my cluster because it has to install a CRD, it has to maintain objects like status of certain objects, so it has to get some access to certain objects. In the example here, MongoDB, so I want to create a database. The service provider has to create the database in the background and write a token secret in my cluster so I can consume it. And finally, it has to create a service object to give me a port I can connect to in my applications. So the service provider claims permissions. That's what you're seeing here. 2 permissions, super limited, super controlled, secure, because it can only do what I allow it to do. And I say, yes, I want, it can write this secret, and it can create one service with a special name, the same name as my database object. So let's say, yes, and we have the API in our cluster. There's nothing running in my cluster, so I can of course use the API. So here's a MongoDB, my pod database for whatever application it is. So I create this object, so apply, everybody knows that, now I have a database. But the point is, if I now look into my cluster, there's nothing running. I mean, there's stuff running, but it's all infrastructure stuff. Metric server, Calico for my networking, core DNS, and some storage provider, but no MongoDB, right? And again, claim is Kube does not support SaaS. It does not support this model. I cannot get APIs which are functional without running some glue, some operator locally. An operator I have to maintain, and I have to make sure it runs in a year as well. All right, so there's nothing running, but there are objects, so I created my pod database, and I can take a deeper look here, so there is status. It's running, so phase running, condition is ready, everything is fine. And I can go forward, I can check, is there a service my application can run? Yeah, it was created. The only thing which connects my cluster to some cloud provider or internal service IT team is an API binding. So there's a binding between cluster and the service provider. We call it an API binding. In this case, it's MongoDB, some URL, it's phase connected, 11 minutes old, and it connects Kube natively to a SaaS service. That's what this is showing. Nothing running, nothing to maintain, nothing to think about. The service provider is responsible that this API keeps running as long as there are consumers of the API. So this is basically, this could be a flow for a user. What have we seen technically? What is behind that? What is Kube really missing here? And the first thing, we have CRDs, but CRDs are just data. They are just objects. There's no logic at all. We need something on top of CRDs. We call it an API binding. And it binds in your cluster here on the right side, a certain type, like in this case, a MongoDB object type to something on the provider side, and we call it an API export. So the export defines which resources are part of this service and where they're coming from. So it's version 1-48 at the moment. So of course there's evolution of APIs. The service provider maintains the export, and the service provider maintains CRDs in your cluster. It's not your problem. You don't have to maintain CRDs. Everything is done as a service, end to end. So a binding and an export we need. We need security, right? This must be secure. When you think about it, there's a service provider connecting to my cluster. What does this mean? People think, oh, I give him a service account, I give him API access, and I hopefully use Airbag to make it secure. No, we don't want that. In this case, what we want is that the service provider gets exactly the access the service provider needs for the service. So in the example here, on the right side, there's a binding, the token secret, and the service. Those two things needs to be accessible. Of course, the MongoDB object itself as well. But everything else I have in the cluster, like service accounts, deployments, config maps, whatever, is not interesting for the service provider. The service provider should not even see and know it exists. So we need something for that. One pattern to do that is permission claims. Everybody knows permission claims, I would say, in this room. Everybody will have some mobile device. And today, if you install applications, applications ask for permissions on your device. Like it asks for, I want the camera, I want to access your position via GPS, or I want to see your contacts. The same model can be basically implemented in Kube. So a service provider can ask for certain things in your cluster, nothing more, very specialized for software as a service. And we need a mechanism for that, obviously. So what we can do, we saw the binding. The binding can have a field or some slice here about permission claims. Permission claims you have accepted. You remember I said yes in the beginning. I want to allow those two claims. That's exactly that. In this moment, the claim would be added here, and from this moment on, the service provider who claimed access to certain objects, like a secret here in this example, which is named according to the token secret inside of the MongoDB object. So it's very different to Airbag. Airbag is very limited. This is much more powerful. And when I say yes, the service provider gets exactly that access. We can go a step further. So everybody knows this, I guess. I'm not sure they look different, maybe in other countries. Who has that in the basement, in some box in the basement? Many people. So it's installed by your electrician, and it's a fuse. And there is this anti-tamper seal below, right? So you see there is something which closes it for your access. Which means you have a contract with your electricity service provider that this object, although it's owned by you, it's even in your basement, it's owned by you, it's your thing. You could touch it, you could even open that. But you have a contract that you cannot do that. And the same thing we can also do here. And one example we have seen already implicitly, the MongoDB object has a spec. You own the spec, right? You say, I want this database in US West 1 and dedicated tier and so on. That's your area, the green one. But the status is not your area to touch. This is, it's basically something the service provider will reconcile all the time. And this is very similar to this seal which we have here. Of course, a seal, anti-tamper seal, you can open, like you can use some cutter, some knife, and open it. Technically, you can do that, but the reconcile will, of course, override everything you have put there, and it will have consequences. Next time your official electrician comes, he will notice, oh, the anti-tamper seal is broken. You broke the contract, basically. One step further, you could even have objects. So I said the whole fuse is it's in your ownership, like you own the fuse actually. So this is similar to this example here. It's a claim where the service provider takes your permissions, like your right on this object, away from you by contract. Same thing here. Imagine, a resource quota thing might be something like that. So maybe you should only be able to create 5 databases because your IT department says so. So they could inject something into your cluster which you don't have access anymore, although it's your cluster. Again, it's not a 100% security, it's more like a contract thing. So you can override it, but it might have consequences for the relationship between you and the service provider. So 3 patterns, there are certainly more, but those things you need if you want to build a service provider pattern into Kube. Like, we need bindings, you need exports. The bindings are in Kube, the exports are somewhere else. I don't talk about that so much here. The bindings are the focus. You as a user create a binding using a nice CLI and UI tool, whatever, and you need a security mechanism like claims, permission claims, and those inverse things like the anti-tamper seal. And that was my claim. We don't have that today, right? We have CRDs and we have operators. Think 3 years ahead, you don't need an operator anymore to get a database like MongoDB from a service provider into your cluster. Or think back about the Jupyter example. Your IT department needs tools to offer users Jupyter API. It doesn't exist. There's nothing like that in Kube. In the whole ecosystem, there's nothing. There are attempts like Crossplane is here with the booth. They build tools to compose CRDs and build new APIs. This might be a good tool for that. So if you want to offer Jupyter as a service in your own company, we have to build tools for that. And this is basically the manifesto here, the ask. We as a community have to build those things. We haven't built them. We have stopped in 2016 with CRDs and some glue code, which doesn't have any value. Just it connects a non-native world with the Kube world. So to sum up, we want that, like we want those 2 directions. Tooling, standard tooling, and I talk about standard, like every cloud provider has controllers, operators you can install. That's not what I'm talking about. I'm talking about a standard SaaS mechanism, which everybody can use to bind APIs from anywhere into your cluster, and you don't have to care about how APIs are implemented. They are just there and they work. And both ways are missing, both we have to build as a community. So that was one of the first slides. We need something like something post-operator. Overcome this idea, everything must be a CRD, everything must be an operator, and then it's somehow Kube native. It's not. It's not Kube native. So service provider persona does not exist in Kube, and we need it. Securely is a keyword here. You have seen the claims. That's a solution. There might be many more discussions around that, how to implement that. But we want Kube native services based on the SaaS pattern in Kube.
Yeah, and we really want to have something in the next 3, 4, 5 years and building like really the future and enable also different teams to work together over an API and not like, okay, I create a ticket. So let's build this, let's start thinking into that direction, and let's figure out what's missing. So thanks a lot, and we definitely need all of your feedback. Thanks.
Let's see. Thank you. We already have some questions. Are you ready?
Yes.
You're coming with me in the center, or you want to hide behind your laptop a bit?
What about air-gapped Kube? So I simplified, of course. There are operators which have value. Operators which implement operational knowledge and self-host the operand. Those are completely valid operators. We don't want to touch them, so they are safe. What we are talking about are operators which are just glue. operators which implement APIs because the cloud providers and the IT teams don't implement Kube native services. Those we want to replace and build something better. If it's air-gapped, everything must be local. So we don't solve the problem that software as a service has in those environments. That's not our goal.
Okay, I want to pull you with me on the other side, because I think for the online audience, they only see you standing right behind each other. And when we stand here, we can read that. And some people can see us.
It's a CAP to integrate service provider interface inside of Kubernetes.
So no, there's no CAP. You're one of the first audiences seeing this engagement, this pitch for new patterns. There have been attempts, like there have been the service catalogs a few years ago, other ways to implement services somehow, but they don't go deep enough into the API machinery of Kube. Like on top, you can build everything, but it's not native. It's still something on top. It's not implemented everywhere. We want it much, much deeper in Kube.
Yeah. Who is able to act as a service provider? What is needed to do so?
I mean, the idea is really that basically everyone can act as a service provider. So we see this pattern everywhere. Of course, the big hyperscalers are currently service provider. You consume their service, but there we don't have this native integration. But think about in an enterprise or in your different development teams, you also want to provide this. And currently, if you want to provide this, you completely need to build this whole machinery, how you can provide this, how they can consume it. And there's a complete gap missing. So a lot of people start using Kubernetes, and then you realize, why should I deploy my database into my application cluster? I want to have a database cluster, or I want to have a load balancer cluster, and I only want to consume it as I'm used to it from the cloud as well. And so that I can do similar things as the big hyperscalers has, also in my own environment, or using specialized services like MongoDB, Confluent, or in an easy and consumable way so that I can consume their services.
What's the difference to Open Service Broker API?
I think the big difference is that we don't need infrastructure in your cluster. Like it's very, very slim on the consumer side. We don't need anything server side. I mean, every service basically can provide this on their own, and everybody can consume it with a very simple agent model, basically, or something very standardized, very simple.
We don't have that much time, so please vote for your most important questions to make sure it gets answers. How do you lifecycle API binding on the customer side?
Basically, in the same way that service providers, cloud providers today version their APIs. They decide when APIs get an evolution, like get a new version. Service providers are responsible for the CRDs in your cluster. It's their responsibility. If you pay money, they are responsible to do safe evolution of CRDs. Because they can do that. They know how the API will evolve. They are responsible already for creation of the CRDs, of the schemas. So they have this knowledge. You don't. Like you consume whatever comes from the ecosystem or what comes from a cloud provider. You cannot have this responsibility. The cloud provider, the service provider, is much more suited to do that as well. So we need safe, secure access to that, of course. But the CRD object, the binding, which is basically abstracting the CRD, is maintained by the service provider as well.
Okay, I think we do the questions with 7 and 5 votes. Why hyperscalers abandon service brokers and move towards operators in Kubernetes?
That's a hope that if we have such a thing, we can get rid of many of those operators which are out there and simplify the world of Kubernetes service consumption.
And last question, is there a working draft or RFC available yet, which people can read or contribute to?
Yeah, I didn't want to mention that. So there's a KCP project, and lots of the work you have seen here is implemented in the walled garden of KCP. lots of the ideas come from that area. So, which means we have an implementation which is many months old and used for advanced stuff. What we don't have is this connection to Cube. The idea here is that we need this model and can enable Cube as well and bring basically the whole Cube ecosystem to a level where we are now with KCP. So code exists, APIs exist. This is a pitch basically that we want to bring that to Cube and not only to the KCP world, which is a little bit, it's a walled garden at the moment, and we want to open that.
Yeah, and if you're interested in looking into this topic, ping Stefan, ping me, and then we can think about also how can we make this happen. And we're definitely looking there and want to start really get this independent from KCP and get there some code that everyone can use this with Kubernetes.
Yeah, and we're going on coffee break now, so it's the perfect time to catch the two of you. I forgot your card decks on my place, so I will hand them to you afterwards. Thank you so much, Stefan and Sebastian.
Thank you.